Since ChatGPT was launched in the fall of 2022, everyone has been trying their hand at prompt engineering, finding a clever way to formulate their queries for a large language model, LLM, or an AI art or video generator to get the best results, or bypass safeguards. The internet is flooded with prompt engineering tips, cheat sheets, and advice threads to help you make the most out of an LLM. However, recent research suggests that prompt engineering is better performed by the AI model itself, rather than by a human engineer. This has cast doubt on the future of prompt engineering and raised suspicions that a significant portion of prompt engineering jobs might be a passing trend, at least as the field is currently envisioned. What is the current state of prompt engineering? In the commercial sector, companies are now working with LLMs to build product copilots, automate tedious tasks, create personal assistants, and more, says Austin Henley, a former Microsoft employee who conducted a series of interviews with people developing LLM-powered copilots. All companies are trying to use it for virtually every use case they can think of, says Henley. To do this, they've enlisted the help of professional prompt engineers. Most people with this job title perform a variety of tasks related to managing LLMs, but finding the perfect phrase to feed the AI is a core part of the job. This widespread approach to prompt engineering has led to a proliferation of techniques and strategies, many of which produce inconsistent or unpredictable results. This has prompted researchers to question the effectiveness of manual prompt engineering approaches and seek more reliable and efficient alternatives. Rick Battle and Teja Golapudi from the California-based cloud computing company VMware were puzzled by the unpredictability of LLM performance in response to quirky prompting techniques. For example, people found that asking a model to explain its reasoning step by step, a technique known as chain of thought prompting, improved its performance on a range of math and logic problems. Even stranger, Battle discovered that giving the model positive prompts before presenting the problem, such as "this will be fun" or "you are as smart as ChatGPT," sometimes improved performance. Battle and Golapudi decided to systematically test how different prompt engineering strategies affect an LLM's ability to solve elementary school math problems. They tested 3 different open-source language models with 60 different prompt combinations each. Specifically, they optimized a portion of the system message of the prompt, which is automatically included in each query before the elementary math problem is presented. What they found was a surprising lack of consistency. Even chain of thought prompting sometimes helped and other times hurt performance. The only real trend might be no trend, they write in their paper on the subject. What is best for any specific model, dataset, and prompting strategy will likely be specific to the particular combination in question. There is an alternative to the trial and error style of prompt engineering that has produced such inconsistent results: asking the language model to craft its own ideal prompt. Recently, new tools have been developed to automate this process. Given some examples and a quantitative success metric, these tools will iteratively find the ideal phrase to feed the LLM. Battle and his collaborators found that in almost every case, this automatically generated prompt outperformed the best prompt found through trial and error. And the process was much faster, taking hours instead of several days of searching. The ideal prompts that the algorithm produced were so bizarre that no human would likely have created them. I literally couldn't believe some of the things it generated, says Battle. In one case, the prompt was simply an extended reference to Star Trek. Command: we need you to chart a course through this turbulence and locate the source of the anomaly. Use all available data and your expertise to guide us through this challenging situation. Apparently, thinking it was Captain Kirk prepared this particular LLM to perform better on elementary school math problems. Battle explains that optimizing prompts algorithmically makes sense, given what language models really are: algorithms. A lot of people anthropomorphize these things because they speak English. No, they don't, says Battle. They don't speak English. They do a lot of math. Indeed, in light of his team's results, Battle suggests that no human should manually optimize prompts again. Image generation algorithms can also benefit from automatically generated prompts. Recently, a team at Intel Labs, led by AI research principal scientist Vasudev Lal, embarked on a similar quest to optimize prompts for the image generation model Stable Diffusion XL. It seems more like a bug of LLMs and diffusion models, not a feature that you have to do this specialized prompt engineering, says Lal. So we wanted to see if we could automate this kind of prompt engineering. Lal's team created a tool called neuroprompts that takes a simple input prompt, like boy on a horse, and automatically enhances it to produce a better image. To do this, they first started with a list of prompts generated by human prompt engineering experts. They simplified these expert prompts down to their most basic versions. Then they trained a language model to transform simplified prompts back into expert-level prompts. The next stage was optimizing the trained language model to produce the best images. They fed the expert-level prompts generated by the LLM into Stable Diffusion XL to create an image. Then they used PicScore, a recently developed image evaluation tool, to rate the image. They fed this rating into a reinforcement learning algorithm that fine-tuned the LLM to produce prompts that led to better scoring images. Here too, the automatically generated prompts outperformed the human expert prompts that they used as a starting point, at least according to the PicScore metric. Lal found this unsurprising. Humans will only do this through trial and error, says Lal. But now we have all this machinery, the complete loop that is completed with this reinforcement learning. That's why we're able to surpass human prompt engineering. The resulting neuroprompts tool transforms simple prompts like a spotted frog on a bicycle into optimized prompts. A spotted frog on a bicycle, intricate, elegant, highly detailed digital painting, art station, concept art, soft and sharp focus, illustration, art by Art Germ and Greg Rutkowski and Alphonse Mucha and William Adolphe Bouguereau, and beautiful and stunning and Revel pairing, and detailed and intricate stained glass, and elegant and splendid, generous, creamy. Lal believes that as generative AI models evolve, whether they are image generators or large language models, the strange quirks of prompt dependency should fade away. I think it's important that these kinds of optimizations are explored and eventually integrated into the base model itself, so you don't really need a complicated prompt engineering step. What does the future hold for prompt engineering? Even if automated prompt tuning becomes the industry norm, prompt engineering jobs in some form won't disappear, says Tim Kramer, Senior Vice President of Software Engineering at Red Hat. Adapting generative AI to industry needs is a complex, multi-step endeavor that will continue to require humans in the process for the foreseeable future. I think there will be prompt engineers for a long time, and data scientists, says Kramer. It's not just about asking the LLM questions and making sure the answer looks good. There are a number of things that prompt engineers really need to be able to do. It's very easy to prototype, says Henley, who studied how copilots are created in his role at Microsoft. It's very hard to put it into production. Prompt engineering, as it exists today, seems to be a big part of building a prototype, Henley says, but many other considerations come into play when you're creating a commercial-level product. The challenges of making a commercial product include ensuring reliability, for instance, gracefully failing when the model goes offline, adapting the model's output to the appropriate format, since many use cases require non-text outputs, testing to ensure the AI assistant won't do something harmful even in a small number of cases, and ensuring security, privacy, and compliance. Testing and compliance are particularly difficult, says Henley, because traditional software development testing strategies are poorly suited to non-deterministic LLMs. To tackle these tasks, many large companies are pioneering a new area of work, large language model operations, or LLMOps, which includes prompt engineering in its lifecycle, but also involves all the other tasks necessary to deploy the product. Henley says that the predecessors of LLMOps specialists, machine learning operations, MLOps engineers, are better positioned to take on these jobs. Whether job titles will be prompt engineer, LLMOps engineer, or something entirely new, the reality of the work will continue to evolve rapidly. Maybe we're calling them prompt engineers today, says Lal from Intel Labs, but I think the nature of that interaction will continue to change as AI models continue to evolve as well. I don't know if we'll combine it with another category or job role, says Kramer, but I don't think these things are going away anytime soon, and the landscape is pretty crazy right now. Everything is changing so much. We're not going to figure it all out in just a few months. Henley says that to some extent, in this early stage of the field, the only prevailing rule seems to be the absence of rules. It's kind of the Wild West for this right now, he says. Prompt engineering, once considered a crucial skill for harnessing the power of LLMs, is undergoing a significant transformation. With the advent of automated prompt optimization techniques, the traditional role of the prompt engineer is being challenged. However, this doesn't signal the end of prompt engineering, but rather its evolution. As technology advances, we are likely to see a shift in focus from manual prompt creation to managing and optimizing more complex AI systems. Professionals in this field will need to adapt their skills, placing greater emphasis on areas like LLMOps, quality assurance, ethics, and systems integration. The future of prompt engineering, therefore, is not so much about its demise, but about its transformation and expansion. As with many areas impacted by AI, humans won't be replaced, but they will need to evolve in their roles, working alongside increasingly sophisticated AI systems. As we navigate this AI Wild West, one thing is certain: the ability to adapt and evolve will be crucial for professionals who want to stay at the forefront of this rapidly changing field. So if you want to learn more about prompt engineering, I've left a link below where you can dive deeper. Click on the like button, share, and comment below if you'd like a part 2 talking about LLMOps. Have a great day, and take care.